All right, 2009, number 6, no TI. We have a fun looking graph, and I've got a really fun looking equation here. Let's see what we can do. Part A, from -4 to 4, find all values on the graph, find all values for which the graph of f has a point of inflection and justify your answer. Keep in mind, you have the graph of f prime. I want to know, when does f have a point of inflection? So let's justify. F has an inflection point when f double prime is 0 or DNE and has a sign change. Now, if I'm looking at f prime, I need to go up a derivative. Therefore, I'm looking at horizontal tangents and sharp turns. Horizontal tangent means the second derivative is 0. Sharp turns means the second derivative is DNE. That's when x is -2 or 0. So that's my answer to part A. Part B. Find f of -4 and f of 4. This, I think, is the bulk of the question. It's the hardest part of this question right here. So let's think about this. Everything I have been given is f prime. I have a piecewise function for f prime, and I have a graph for f prime. They're asking me about f. So if I have information on the derivative and they want me to go back to the original, I need to integrate something. Here's the trick. If I integrate f prime of x, I get f of x. I think you can understand that thought. Now, if I throw limits on this, let's say because I'm looking for -4 and 4, if I put -4 and 4 as my lower and upper limits, then I would get f of x evaluated from -4 to 4. However, if I look at this, I plug in my upper limit minus my lower limit. That means the two things that I'm looking for are in the same equation. That's no good. I want an equation with one unknown. So what I want to do is I want to evaluate from -4 to 0 f prime of x, because if I integrate f prime, I get f of x evaluated from upper limit to lower limit. So now, if I look at this, the right-hand side, if I sub in my upper limit, I get f of 0 minus f of -4. Well, guess what? We know what f of 0 is. That was given to us. We were told at the beginning that f of 0 is 5. So I can sub that in and get that as a 5. Here's the other important part of this. If you look at this, you have the graph of f prime. So if you integrate from -4 to 0 f prime, that's asking you to find the area under the curve from -4 to 0. So we need to find the area under the curve from -4 to 0. So what we need to do, break that up into a rectangle and then subtract the semicircle. So that is what we're going to do. So to evaluate this, I'm looking at, this is all the area under the curve, because this is the graph that we have. So the area of my rectangle is 8. The area of my semicircle is, let's see here, pi r squared divided by 2, so you get a 2 pi. Therefore, this whole integral right here is equal to 8 minus 2 pi. And that is equal to f of 0, which is 5, minus f of -4, which is what we're looking for. So what you want to do, if I add f of -4 over, equals 5, and I'm subtracting everything. So then f of -4 is equal to, let's see here, that's going to become 2 pi minus 3. That's f of -4. Now, here's the hard part. That was the easier one. We have to do all of this all over again and find f of +4. Here we go. Exact same idea. I'm going to integrate from 0 to 4 f prime of x dx. Because if I do that, when I integrate f prime, I get f of x from upper limit minus lower limit. So this will give me f of 4 minus f of 0. I want to use this because this is the value we know. We know that f of 0 is equal to 5, therefore that's my unknown. here. I need to find the area under the curve of f prime. If you look at this graph, these are not shapes that we can find the areas of. Okay, this was exact. I could find the exact area under the curve. I can't here. So for me to integrate from 0 to 4, I'm actually going to have to use the formula they give me. That's why we have that piecewise function. So what I need to do here is I need to find this piece of it. I need to integrate from 0 to 4, f prime, which is actually equal to 5e to the negative x over 3 minus 3. So I'm just going to worry about this integral right now and integrate the left-hand side, okay? I'm going to split my integral. 0 to 4, 5e to the negative x over 3 dx minus the integral 0 to 4 of 3 dx. Now, the reason I'm splitting this is because to integrate the 5e to the negative x over 3, I need to do a u sub. Let u equal negative x over 3. du will then be a negative 1/3 dx. Put the reciprocal out in front. This becomes negative 3, the integral of 5e to the u du. Okay? Now, when I integrate this, I get 5 is a constant. I can pull that out in front. Negative 15 e to the u, well, e, and then my u is negative x over 3, and I'm evaluating that from 0 to 4. Minus, don't forget about the other integral that we split. When I integrate 3, I get 3x, evaluate from 0 to 4. So let's see what happens here. I need upper limit minus lower limit. So I get negative 15e to the negative 4/3 minus, and then when I sub in my lower limit, negative 15e to the, well, negative 0 divided by 3, 0 divided by 3 is just 0, minus, this is this subtraction sign, I have to evaluate 12 minus 0. So if we look at this, all right, I've got negative 15e to the negative 4/3. E to the 0 is 1, so this becomes plus 15, and then over here, minus 12. So what I have, let's see here, I've got 3 minus 15e to the negative 4/3. Now, if you recall, that was, this right here is the answer to the left-hand side of this integral. So what we just got, 3 minus 15e to the negative 4/3, that is equal to f of 4 minus f of 0. So that's where I'm going to pick this up. I'm just bringing down all of this given information from the original. Bring that down. I've got 3 minus 15e to the negative 4/3 is equal to f of 4 minus f of 0. Now we know that f of 0 is 5. Guys, we're almost there. F of 4 minus 5. Add 5 over, and you get f of 4 is equal to 8 minus 15e to the negative 4/3. And that's your second answer for part B. That was a lot of work, okay? Here's the good news. Part C. On my closed interval, find the value of x for which f has an absolute maximum and justify your answer. This one is not so bad. If you look at this, my justification, f has a max when f prime is 0 or d and e, and I have a sign change plus to minus. I set up my number line. I know that f prime is 0 at negative 2 and 3 ln of 5/3. That was given to me. I know my graph is above the x-axis, above the x-axis, below the x-axis. Therefore, increasing, increasing, decreasing, this is the only possible answer. That is my absolute max when x equals 3 ln of 5/3. Hope that all makes sense.